Dear students of class 9, welcome to you all in higher mathematics class. The students of class 10 can also take part in this class. This is lecture 3 on the topic infinite series. And this topic is discussed in your book at chapter 7. I am Shudipan Bhattacharya with you. Today we are going to learn about some objectives. After this class, we will be able to explain infinite sum of a series, condition of existence of infinite sum of an infinite series, condition for a geometric series to have infinite sum, find the infinite sum of a geometric series. So now we are going to try to understand what what the term infinite sum means. Understanding an infinite sum. Let us start with a visual example. A series is as follows: half plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 plus dot dot dot. So pause the video for a minute and think about it. What does it mean physically? Uh, this is a mathematical notation: 1 by 2 plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32. You can read it as a series, but what does it mean in practical? What does the series may present? Now, after thinking, now come to the point that suppose your mother made a cake for you and she told you that every bite you must eat exactly half of the remaining cake. Every bite you must eat exactly half of the remaining cake. So at the first bite you have to take half of the cake. At the second bite you will have to take 1/4 of the cake, because half in the half of half, that is 1/4 of the cake. And third bite you have to take half of 1/4, that is 1/4 of the cake, like this. At the first bite you ate the half of the cake. How many bites will it need to finish the cake? Now suppose this is the cake. This is a chocolate cake. Your mother made it for you, though the color is not actually chocolate, it is brown color. Whatever, take it for a cake. Now, at the first bite, you have eaten the half of the cake. So, it is like this: you have eaten the half of the cake. Now, at the second bite, you have eaten half of the remaining half cake, that is half of the remaining half, that is 1/4 cake. At the third bite you will have eaten half of the 1/4, that is 1/8 cake. The next bite you will be eating 1 by 16th part of the cake. At the next bite you will be eating 1 by 32 part of the cake, and so on. You will be eating, next bite you will be eating 1 by 64th part, 1/64th of the cake, and next bite you will eat 1/28th of the cake, 1 of 1/28th of the cake, and so on. After that you will get 1 by 256 part of the cake, and then at the next bite you will eat 1 by 5 12 512 part of the cake, and so it will carry it on. But if you go mathematically, you can realize that the cake will never finished. The cake will be never finished. After infinite bite, you will have a small and small and smaller and very smallest piece of the cake. So uh, this is what uh, an infinite geometric series means. First, at the first bite, you have eaten half, then 1 by fourth, then 1 by eighth, then 1 by 16th, then 1 by 32, then 1 by 64, then 1 by 128, then 1 by 256, then 1 by 512, 512, and so on. It will be carried out up to infinite number of times, but the cake will not be finished. We can say that when you will bite infinitely many times, or you will take infinitely many bites, then the cake will be finished. To finish the cake, you have to bite infinite times. So now I think you can understand the question. Uh, so you can find the answer. You can never finish that hypothetical cake if you can measure your bites mathematically. In other words, it can be said that you will be able to finish the cake by infinite bites. By the way, suppose you have finished the cake by infinite number of bites. How much of the cake have you eaten? By infinite bites, you didn't have eaten, you didn't have, by infinite bites, you have not um, eaten infinitely many cakes. You have only eaten only one cake. So, what does it mean? The conclusion is half plus 1 by 4 plus 1 by 8 plus up to infinite number of terms of the series after infinite number of bytes. The result is, if you sum up all the bytes, you will get one cake, only one cake. So this is what infinite sum means. Infinite sum means uh, taking sum of infinite terms of a series. And sometimes if you take the sum of infinite number of a series, then it will become a finite number. Suppose we have taken half plus 1 by 4 plus 1 by 8 plus to so on up to infinite terms. But the sum is finite. The sum is 1. So, what is the condition? I have said that sometimes we will have this kind of thing, that taking the sum of infinite number of terms of a infinite series, of an infinite series, and we will get a finite number as a sum. What is the condition of existing infinite sum of a series? Uh, Not all the series have infinite sum. Only the series whose terms are converging to a certain number has infinite sum. This kind of series are called convergent series. So the series which are converging to a number, uh, converging to a certain number, uh, they have only infinite sum. So what does it mean by converging to a number? It is like approaching to a fixed number, uh, such as the series half plus 1 by 4 plus 1 by 8 plus 1 by 16 plus 1 by 32 is converging to 0. How can I understand that in the series is converging to 0? Uh, if you look at the numbers carefully, the first number is half, and the second number is smaller than half, and the third number is smaller than 1 by 4, half of 1 by 4, and then 1 by 16. 1 by 16 is less than 1 by 8, and every term it is decreasing the terms. Every term by term the series is decreasing to a point. And if you compare it to the cake, first bite you have taken half, and the second bite you have taken 1 by 4th, and at the third bite you have taken 1 by 8th. And uh, what will happen after 100 or 200 bites? After 200 bites, how much bigger, however bigger the cake be, it will turn into the bites will turn into very small, and it will approach to zero. So we can say that this series is converging to zero, because if you consider that the last term, which will be the last term of this series, we don't know which will be the last term of the series, but we can assure it the whatever the term is uh, at the end, or near to the end of the series, it will be very close to zero. So the term, uh, as far as we go, the term will approach to zero. As far we go, we will see that the terms is becoming zero. So this series is called convergent, and this series is converging to zero. So if any series if you can find any series which is convergent, which is converging to a certain number, it is either 0, either 1, 2, 3, 4, or any number, this series will be having a infinite sum. Whatever, uh, there can be many types of convergent series, and there are many ways to test convergency of a series. If the series is very complicated, it is very tough to find out whether it is convergent or divergent. Divergent means not convergent. If the series is very complicated series, uh, I have told you that series can be complicated, series can be easy. If the series is very complicated, then it will be very hard. It may be very hard to find whether it is convergent or not. So there are many ways to test the convergency of a series, which will you, which is the topic of honors. Uh, now, now in our text, we will be discussing only about convergency of geometric series. We will only discuss about geometric series. If a geometric series is convergent, that is approaching to a certain number, then the geometric series will have infinite sum, that is sum of infinite number of terms. Infinite sum means sum of infinite number of terms of a series, sum of all the numbers of a series up to infinity. So when we can say that a series have infinite sum if the series is convergent to a number. When we can say that a series is convergent if the terms are approaching to a number. Okay, I think you can understand this. Now we will be discussing about infinite sum of geometric series. Look at the following geometric series. First one is like this: 1 plus half plus 1 by 4 plus 1 by 8 plus 1 by 16 plus dot dot dot, and so on. And second one is like 1 plus 2 plus 4 plus 8 plus dot dot dot. Which one is convergent and why? Look at the first one. The terms are decreasing term by term. as you go further, the terms are decreasing sequentially. 1, then half, then 1 by 4, and 1 by 8, then 1 by 16. So we can say that the series is approaching to 0. And look at the second series. The terms are increasing as far as you go. Terms are increasing one by one. So we can say that first one is convergent because terms are decreasing and approaching to 0. And second one is not convergent, that is divergent, because terms are increasing and approaching to a very big number. If you find out the 100th term of the first series, you will get a very small number. And if you find out the 100th term of the second series, you will get a very big number, and so on. If you find out the 1000th number, it will be very small number for the first series. And if you find out the 1000th number of the second series, it will be very big number. So when a geometric series is such that the such that as you as you take a greater number as a term number, like as you make the n bigger, the terms become smaller. And if you take a big value of n, and the terms get bigger, then it is divergent series. So here you can see that first one is convergent and second one is divergent. When the common ratio of a geometric series is in between -1 and 1, that is negative or positive proper fraction. If the ratio is a proper fraction, which might be negative or positive or 0, then the geometric series convergence. Convergence means have infinite sum. So if you are asked that when a geometric series have infinite sum, your answer will be like this: if the common ratio of a geometric series is in between -1 and 1, then the series is convergent and will have infinite sum. When the common ratio of a geometric series is greater than or equal to 1 or less than or equal to -1, the series is not convergent and does not have infinite sum. If it is equal or greater than 1, or it is less than or equal to -1, then the series is not convergent and it will be called divergent. And a divergent series does not have infinite sum. If the common ratio is R and uh, -1 is less than R is less than 1, a geometric series has infinite sum. So the summary of the previous two points is -1 is less than equal to R and R is less than equal to 1. If this kind of situation occurs, then we will say that the series is geometric series. This this can be also expressed by modulus of R is less than 1. When you are said that modulus of R, that is two bar signs uh, before and after R, that is modulus of R. This means modulus sign. Modulus of R is less than 1, then you can say that -1 is less than R is less than 1. Modulus means uh, if you have to forcefully make it positive. That is, if you are given minus 3, then modulus of minus 3 is 3, and if you are given 3, then modulus of 3 is also 3. That modulus means the positive value uh, of a number. If a number is forcefully made positive or non-negative, if a number is forcefully made non-negative, then it is called the modulus of the number. That is, you are given minus 7. The modulus of minus 7 is 7. You are given 3. Then modulus of 3 is 3. Uh, Whether it is positive or negative, if you put a modulus, then the result will be positive of this number, positive value of this number. So modulus of r is less than 1. Modulus of r less than 1 means that minus 1 is less than r is less than 1. Now we are going to calculate the infinite sum of a series. So we are going to need some formula to calculate the infinite sum. So recall the formula of finite sum of a geometric series. The finite sum of a geometric series was like Sn equal to a into 1 minus r to the power n divided by 1 minus r. When modulus r is less than 1, that is the value of r is a proper fraction, uh, denominator is greater than the numerator. Uh, the modulus of r is a proper fraction, whether it is negative or positive. Modulus of r is less than 1, then r to the power n is very small when r is very big. Uh, to understand this, let us go to a calculator. Suppose you are given, you take the value of r equal to a number which is between minus 1 and 1. So I will take minus 0. 0.4. 0.4 is between minus 1 and 1. Now I will put the power, I will put the power 3. Look at this result. The result is very small, which is close to 0, 0.064. If we put the value 4, then this is very closer to 0. If we put the value 5, and more close to 0, 0.01, which is more close to 0, and if we put the 6, then 0.004, which is very close to 0. If we put 12, then you can see that 1.666777 to 16 into 10 to the power minus 5. 10 to the power minus 5 means 0.00001 6777, 0.00001. After the decimal point you will get 4 zeros and then you will get 1. So this number is very close to 0. If we put 100 as the power, you can see uh, the number is very small. If we put 1000, then you can see that the number is so small that the calculator is showing 0. And if we put another 0 here, uh, power 10,000, the number is so small, so small that calculator cannot even able to calculate the proper value. It is showing the approximate value, which is 0. So if you take a proper fraction, whether it is positive or negative, if you take positive number as the value of r, if you take positive number, and the value of n is very big, like 10,000, 1 million, 2 million, then the result is 0, approximately 0. It is so close to 0 that we cannot calculate the exact value. We say that the value is so close to 0 that we take it for 0. If we put the value of r as a proper fraction, that is 1 by 3 or 0.25, r is smaller than 1 and greater than minus 1, and the value of n is very big, that is we are going to find out the infinite sum, that is n, the sum, the value of n will be very big as infinity. So we can say that this part 1 minus r to the power n and minus r to the power n will be 0. So what will remain, that a into 1 minus 0 divided by 1 minus r, and it will get you will get that a by 1 minus r. So we can say that the formula for finding infinite sum of the geometric series ar to the power ar square ar cube plus dot dot dot, where r is in between minus 1 and 1, is s infinity equal to a by 1 minus r. S infinity equal to a by 1 minus r. It can be written like this: summation of ar to the power n, where n goes to 0 to infinity, and then it is equal to a by 1 minus r. Sign is called summation, which is this letter. This is a Greek letter called sigma, Greek capital letter, capital form of sigma is like this, sigma. It stands for summation. Wherever you see this term, you will be you will learn that, or you will understand that this means a summation of this type of terms, where the values of n varies from 0 to infinity, like 0. uh, the first term it will be the value of n equal to 0, at the second term the value of n equal to 1, at the third term value of n equal to 3, uh, so on it will continue up to infinity. So if you see this kind of term, if you have to elaborate it like this: a plus ar square plus ar cube, like this, and it is equal to a by 1 minus r. Now we are going to calculate some infinite sum uh, of given series. Find the infinite sum of the series if exists. First, we have to check whether the sum infinite sum exists or not. Then we have to calculate if exists. So we take the first one, 1 minus 1 by 4 plus 1 by 16 minus 1 by 32 plus dot dot dot. Look at here, the second term by first term equal to minus 1 by 4. The third term divided by second term is minus 1 by 4. The fourth term divided by third term is equal to minus 1 by 4, and so on. So we can say that the given series is geometric, where first term a is equal to 1 and the common ratio r is equal to minus 1 by 4. Also, uh, minus 1 by 4 is a number in between minus 1 and 1. So we can say that infinite sum exists. So infinite sum is s infinity equal to a by 1 minus r. Putting the value of r, we get 1 by 1 minus 1 by 4, which is 1 by 1 plus 1 by 4, and calculating this we will get 4 by 5. I think it's very easy. Now for the second math, you will get the series as geometric series, because second term by first term will give us 2, a third term by second term will give us 2, a fourth term by third term will give us 2, and so on. So this term has a constant ratio, common ratio, and this is a geometric series. But The common ratio is r equal to 2, and 2 is greater than 1, which is not in between 1 and minus 1. So we can say that the series does not have an infinite sum. So this is very easy. uh, if you solve, you can, I think, if you only memorize the formula and memorize the condition, then you can easily solve these kind of problems. Now homeworks for you. Go to chapter 7, and you will get this problem number 11. Find the sum of the given series up to infinity if it exists. You have to solve these five maths. Solve these five maths by yourself and submit it to me at the email number I will give in description box. Thank you, and see you in the next class.